Assalamu alaikum, Hassan Turmus from Al Math Schools. Today we will start by Chapter 2, Real Numbers. Our objective is to perform operations on square roots, and we need some materials, textbook, draft papers, pen, and calculator. We should know from grade 8 the definition of the square root, and we will go through the examples directly. Here, 4 is the square root of 16, as 4 power 2 equals 16, then we can write radical 16 equals to 4, or square root of 16 equals to 4. Also, 9 is the square root of 81, as 9 power 2 equals 81, then square root of 81 equals to 9. Keep in your mind, radical 0 equals to 0, and radical 1 equals to 1. Let us start by the definition. If a is a positive real number, then its positive square root is denoted by radical a. So radical a is the square root of a. So radical a to the power 2 equals to a. Examples: radical 5 to the power 2 equals to 5, radical pi to the power 2 equals to pi, radical 5 plus pi power 2 equals to 5 plus pi, radical 3 times radical 3 equals to radical 3 squared equals to 3. Pay attention. Power 2 is cancelled by radical in each of the following cases. Here we have 4 radical 2 squared. This means 4 radical 2 equals to 4 times radical 2. Then the power 2 is taken by 4 and radical 2 to get 16 times 2, and finally we get 32. Pay attention, if a is a negative number, then radical a is not defined. Example, radical minus 2 is not defined. This means we cannot put a negative number inside the radical. Properties. We have this property, radical a squared equal to a, and these the examples about this property. And we see in all of these cases the power 2 cancelled by the radical. Here we have another property. If we multiply two numbers containing radical by each other, we can put these two numbers multiplied inside a one big radical. Here the examples: radical 5 times radical 3, we can write 5 times 3 inside a big radical to get radical 15, and here same, but we have 3 numbers. But in the third one we decompose the big radical into 2 power 2 and 3, and here we cancel 2 by radical to get finally 2 times radical 3 to write 2 radical 3. Here also same as the first example, we multiply the numbers to get radical 36 and we write it 6. We have another property. In case of division or in case of fractions, we write radical a over radical b equals to radical a over b. Let's take some examples. If we have radical 9 over 25, we can write radical 9 over radical 25 and calculate the numerator and denominator each one to get 3 over 5. Here we can write radical 14 over radical 7 inside a one big radical 14 over 7, then simplify to get radical 2. Radical a plus b does not equal to radical a plus radical b. Also radical a minus b does not equal to radical a minus radical b. This is a very important property, and here some examples. Let's calculate radical 25 plus 4 to get radical 29. It is easy. Also radical 25 plus radical 4 equals to 5 plus 2 equals to 7. Pay attention here. Radical 25 plus 4, which is radical 29, does not equal to radical 25 plus radical 4, which is 7. So pay attention for this important property concerning addition and subtraction. This is the first application. Stop the video and try by yourself. Okay, let's start by solution. This is the first one, 3 radical 25 minus 4 radical 16. Here we replace 25 by 5 squared and 16 by 4 squared, and then we write 3 times 5 since we cancel power 2 with radical, and 4 times 4 since we cancel power 2 with radical, to get finally 15 minus 16 equals to minus 1. The second one, the power 2 here is taken by 2 and radical 5. The power 2 is taken by 6 and radical 2. We get from the first one 4 times 5 and we get from the second one 36 times 2, and finally we apply the operations to get 92. Here we have multiplication. We multiply the number outside the radical by the number outside the radical, so minus 3 times 7 equals to minus 21, and we multiply the radicals by each other to get radical 5 power 2, and then apply the operations and calculations to get minus 105. Here also we multiply the numbers outside by each other, so 6 times 2 times 1. Pay attention here. If we don't have any number, this means that we have 1. And this will equal to 12. And we multiply the numbers inside the radical by each other to get radical 5 times 3 times 15. Finally, we get the 12 times 15 to get 180. 5. Here, radical 28 over radical 7. We put a big radical for the whole fraction and equals to radical 4, finally equals 2. Let's move to another property, this property about simplification, and I will start by examples to illustrate this property. Here we have a radical 54. We know from multiplication tables 54 equals to 9 times 6. This means 3 squared times 6. Since 3 is powered by 2, we move this number outside the radical and we write it only 3. 6, we keep it inside the radical since it powered by 1. So the final answer is 3 radical 6. Radical 48. 48 equals to 16 times 3. We can write 16, 4 power 2. And since 4 is powered by 2, we move it outside the radical and write 4. 3 is still inside the radical since it powered by 1 only. Radical 180 equals to 36 times 5. We write 36, 6 power 2, and then we move it outside the radical to write 6 radical 5. Okay. It is not easy to decompose 180 like that, 36 times 5. So we may use sometimes the prime factorization. To use a prime factorization, we write 180 and then we draw a vertical line. Then we divide 180 by 2 equals to 90, by 2 equals to 45, by 3 equals to 15, by 3 equals to 5, by 5 equals to 1. We can write these numbers in this way, 180 equals 2 power 2 times 3 power 2 times 5. Then we replace 180 inside the radical by these prime numbers. And each prime number powered by 2, we move it outside the radical to write 2 times 3 radical 5. And finally we get 6 radical 5. Now radical 0.64. We write 0.64, 64 times 10 to the power minus 2 as in the previous lesson. Then we write this 64 times 10 to the power minus 2 in this way. 8 times 10 to the power minus 1 to the power 2. And if you try to distribute this power into 8 times 10 to the power minus 1, you will get 64 times 10 to the power minus 2. Okay, now we cancel the power 2 with radical to get 8 times 10 to the power minus 1. And this means 0.8. Application. Stop the video and try. Okay, the solution. Radical 63 equals 9. Radical 9 times 7, which is 3 radical 7. Radical 18 equals to radical 9 times 2, which is 3 radical 2. Radical 8 times radical 24 is radical 8 times 24. So, and the 24 is 8 times 3, so 8 squared times 3, and we get 8 radical 3. Radical 49,000, so radical 49 times 10 power 3. 49 written as 7 power 2, and 10 power 3 decomposes 10 power 2 times 10 to the power 1, and then we move the squared numbers outside the radical to get 70 radical 10. We have a new property here. Like radicals, if we have two numbers having the same radical or like radical, we can add these two numbers outside the radical and keep the radical same and don't change the radical. Example, if we have 3 radical 7 minus 5 radical 7, we subtract 3 minus 5 and we keep radical 7. Then we have minus 2 radical 7. if we have radical 5 plus radical 5 plus radical 5, we add 1 plus 1 plus 1, we have 3 radical 5. So we add the numbers outside and keep the radical same. Radical 27, we simplify each of the following according to the simplification rule. Previously, we explained it, and then we find 7 radical 3. Why? Because we have 3 radical 3 minus 10 radical 3 plus 14 radical 3. We keep radical 3 here, and we add and subtract these numbers outside to get 7 radical 3. And here the same, but pay attention. 4 radical 16 equals to 4 times 4. Why? Because radical 16 equals to 4. Then we apply the operations to get finally radical 6 plus 16. Notice here, radical 6 plus 16 cannot be added because 16 having a radical 1 here, but we do not write it. So unlike radical, therefore we cannot add them together. Okay. Application, stop the video and try by yourself. And here the solution. We simplify and then we get minus radical 7. Also in F, we expand minus 3 radical 7 into minus radical 7 minus 1 to get 3 times 7. Minus 3 radical 7 times minus radical 7 is 3 times 7. Minus 3 radical 7 times minus 1 equals to 3 radical 7 minus, we multiply these radicals and we decompose the number inside, which is 28. Then we calculate and we add and subtract the same radicals to get radical 7. Here minus 21 is cancelled by 21. Finally, E plus F minus radical 7 plus radical 7 equals to 0. This means that E and F are opposite numbers. We have this property. It is an important property. If A is positive, then radical A squared equal to A. If A is negative, then radical A squared equals to minus A. Examples, radical minus 5 squared. If we cancel power 2 with radical, we get minus 5. But since we have A here is negative, we put in front of it a minus sign to get finally 5. Another example. Here we cancel power 2 with radical, but we check first. 3 minus pi is a negative number using a calculator. So we put in front of it minus. Then we get minus 3 plus pi or pi minus 3. Another example. Before we cancel power 2 with radical, we check pi minus 1 is a positive number. So easily we can cancel power 2 with radical to get pi minus 1. So we can write this form in two ways, a minus b or b minus a, according to the difference between the two numbers inside the parentheses. Pay attention here, and this is a very important rule. Try to solve this application and stop the video. Okay, solution, true or false with justification. If x minus 2 is less than 0 here, then radical x minus 2 squared is 2 minus x. We reverse it, since inside it is negative. But if inside x minus 2 is greater than 0, without power 2 here, x minus 2, then radical x minus 2 squared is remain x minus 2. So, radical x minus 2 squared is not equal to x minus 2 only for any value of x. So, false. Now in the second part, the first one is not defined. Why? Because we have pi minus 5 is a negative number. According we can check it on the calculator inside the radical. So it is not defined since pi minus 5 less than 0. But here radical pi minus 5 and the square inside, we can write it 5 minus pi reversed. Why? Since the number inside, which is pi minus 5, is negative. So they are not equal. The statement is false. And this is your assignment finally in your textbook. And this is the summary of our lesson. And thank you for watching. Wassalamu alaikum.